You know that feeling when you finally nail a new skill? Or when you push through a tough challenge and come out the other side? What's actually going on in your brain at that moment? It's not magic. It's this incredible symphony of electricity and biology. And today, we're going to unpack the neuroscience behind how our brains build that kind of expertise.
All right, let's get right into it. We're going to tackle this by looking at a really fascinating case study, the cognitive profile of a man named Denis Vrahaj. The core question is this: what is happening, neurologically speaking, that allows someone to not only compensate for something like dyslexia, but also to develop this incredibly flexible, adaptive way of thinking called prismatic cognition? And on top of that, how does the brain teach itself to get better? That's the puzzle we're here to solve.
So, first things first, what even is pragmatic cognition? It's definitely not about being stuck in one way of thinking. Think of it as the total opposite. It's your brain's ability to just switch gears on a dime. You can go from deep, quiet reflection to being totally engaged with what's happening around you, and then immediately adapt to new information. It's like having a mental clutch that lets you shift effortlessly. Basically, it's peak mental agility.
Okay, so here's our game plan. We'll start with the brain's command center, move on to the rhythms of consciousness, then dive into how the brain can rewire itself. We'll explore its self-correction engine, and finally, see how it all comes together in the dance of mastery.
All right, let's kick things off with the brain's command center. To get how the brain pulls off these amazing feats, we've got to get to know the key players. You know, the parts of the brain that are doing all the heavy lifting.
Okay, so think of your brain's leadership team. First up, you've got the prefrontal cortex, the PFC. This is the CEO. It's in charge of the big decisions, the executive functions, and consciously fixing your mistakes, especially when you're learning something new. Then you have the corpus callosum. This thing is like the company's high-speed fiber network, a massive superhighway of nerves connecting the brain's two hemispheres. It is absolutely essential for coordinating complex tasks.
But, it's not all high-level strategy. It's about doing stuff, too. That's where the motor cortex and the cerebellum come in. They're the dynamic duo for action. They handle fine motor control and help us learn from doing things over and over again. And then there's this really cool, sophisticated hub called the temporoparietal junction, or TPJ. Its job is super subtle but so important. It helps the brain figure out the difference between simply paying attention to something and being consciously aware of it. So, how on earth does the TPJ make that distinction? Well, the secret is in the brain's rhythms. It's brainwaves. When you're just focusing, you see these high-frequency gamma waves. That's the brain asking, what am I focusing on? But when you're consciously perceiving something, you see low-frequency gamma waves. That's the brain asking, what am I actually aware of? And this ability to juggle focus and awareness, that is a huge piece of the puzzle for that flexible, prismatic cognition we were talking about. And this process really shows you the path to mastery, right? When you're first learning something, that prefrontal cortex, the CEO, is working overtime, micromanaging everything. But as you practice, the CEO starts to trust its team. It delegates tasks to the specialist sensory motor regions. And finally, once you've reached mastery, the CEO can just kick back. The whole operation runs on autopilot, handled by these now expert regions. The brain literally becomes more efficient. So we've met the hardware. Now it's time to talk about the brain's operating system. This is where brainwaves enter the picture. Think of them as the underlying code, the rhythms of consciousness that coordinate everything. Now, these brainwaves, they're not just random static. No way. They're the brain's internal clock, its rhythmic pulse. And you've got different frequency bands, theta, alpha, and those low and high gamma waves we just talked about. Each one has a job. They're constantly managing what we pay attention to and, crucially, what information actually makes it into our conscious awareness. And get this, scientists have actually pinned down a specific rhythm for this. It's about 8 hertz. That means your brain is taking a snapshot of the world roughly 8 times every single second to construct what you perceive as reality. That's basically the refresh rate of your consciousness. It's this steady beat that allows you to experience the world as a smooth, continuous movie instead of a choppy slideshow. Okay, so we've got hardware and an operating system. The next logical question is, can we get an upgrade? And the answer is a big yes, which brings us to our next part, rewiring the brain, or how the brain installs its own software updates. The fancy word for this is neuroplasticity, and honestly, it's one of the most incredible and hopeful ideas in all of science. It means your brain isn't set in stone. It's not fixed. It is literally built to change, to physically reorganize itself, and to forge new connections based on what you do and what you learn. And the best part? This happens throughout your entire life.
And we're not talking about some abstract idea here. These are real, physical upgrades to your brain. With dedicated practice, you can literally increase the thickness of your cortex, improve your brain's internal wiring, that white matter, especially that corpus callosum superhighway, and beef up the connections in the circuits you use the most. It's like going to the gym for your brain.
And boom, this brings us right back to our main puzzle. This ability to rewire itself is exactly how the brain can compensate for challenges like dyslexia. It's not about fixing the original problem spot, it's about building a workaround. Through targeted practice, the brain physically strengthens other neural pathways to process information. It literally finds another route to get the job done. Okay, but what's driving all this change? What part of the brain is the project manager for all this self-improvement? Well, that would be the self-correction engine, the part of us that learns how to learn. Let's meet your brain's internal mentors. You've got the medial prefrontal cortex, which is what allows you to be flexible and switch up your strategy when something's not working. And then there's its partner, the anterior cingulate cortex, or ACC. Think of the ACC as your brain's built-in error alarm. It's that little pang you feel when you realize you've made a mistake. It literally fires up and tells the rest of the brain, hey, pay attention, that wasn't right. The two of them working together are the foundation for conscious self-correction and real growth. So, let's recap. We've looked at the hardware, the operating system, the software updates, and the self-correction engine. Now it's time to put it all together and watch the dance of mastery. So, what's the big takeaway? The answer to our question, where does mastery live in the brain, isn't a single spot. You can't just point to it. It's a whole system. And this system is, 1, distributed. It involves a ton of different regions all working together. 2, it's rhythmic. All that activity is coordinated by the precise timing of brainwaves. And 3, it's plastic. It's always changing and adapting based on what you do. And that is the solution to our puzzle. It's this whole dynamic network, the hardware like the prefrontal cortex, the software of those brainwave rhythms, and the constant updates thanks to neuroplasticity. That whole package is what makes a complex cognitive profile like this possible. It's how a brain can achieve prismatic cognition, find workarounds for dyslexia, and build that incredible engine for self-correction. So if you take away just one thing today, let it be this. Your brain isn't just a machine that learns stuff. It's so much more than that. It's a machine that learns how to learn better. With every bit of practice and attention, it's constantly upgrading its own systems. And that is just a remarkable thing to think about.